Dear students, welcome to s.mathguru classes. So our main discussion is eigenvalues and eigenvectors. In last two videos, the only eigenvalues are given, how to find eigenvalues, and eigenvectors not given. Now today we start eigenvalues and eigenvectors both. So first we consider a 2 by 2 matrix. Determine the eigenvalues and eigenvectors of the matrix A equal to 5, 4, 1, 2. So solution start. The characteristic equation is given by determinant A minus lambda I equal to 0. So determinant A minus lambda I means 5 minus lambda 4 1 2 minus lambda equal to 0. We subtract lambda from diagonals. So expand this 5 minus lambda into 2 minus lambda minus 4. This into this minus this into this. This is 10 minus 5 lambda minus 2 lambda plus lambda square minus 4 equal to 0. So lambda square minus 7 lambda plus 6 equal to 0. This implies lambda square minus 6 lambda minus lambda plus 6 equal to 0. Lambda minus 6 minus 1 lambda minus 6 equal to 0. Lambda minus 6 lambda minus 1 equal to 0. So we get lambda equal to 6, lambda equal to 1. So eigenvalues are 1 and 6. These two are the eigenvalues. Therefore, eigenvalues are 1, 6. These two are called the values of lambda are called eigenvalues. Now we consider eigenvectors. So for eigenvectors, we find the characteristic equation. Now for eigenvectors, we write A minus lambda I x equal to 0. So we find A minus lambda I x. A minus lambda I means 5 minus lambda. This one 5 minus lambda 4 1 2 minus lambda, and x means x1 x2, and 0 means 0 0. So we get this. This implies A minus lambda means x1 x2 we consider. So multiplying this 5 minus lambda x1 4 x2 equal to 0, x1 plus 2 minus lambda x2 equal to 0. So we consider this is number 1, or we consider this whole is 1, number 1. So we get this equation. Now putting the value of lambda, case 1, let lambda equal to 1. So we putting lambda equal to 1 in equation number 1, lambda equal to 1, then 1 implies 5 minus 1 x1 4 x2 equal to 0, x1 2 minus 1 x2 equal to 0. So this implies we get 4x1 4x2 equal to 0, and this is x1 plus x2 equal to 0. This is number 2, this is 3 you consider. And if we divide this equation by 4, again we get same equation. Now suppose 2 implies or 3 implies 2 implies dividing by 4, then x1 plus x2 equal to 0, x1 equal to minus x2. So x1 by x2 we get 1 by minus 1. So we get this one minus 1 by 1 we get. So this is this one. We can write this, if we write this one minus 1 by this, x1 by 1, x2 by minus 1. We write this one here, this one here. This is equal to k1 we consider. So x1 equal to 1 k1, x2 equal to minus 1 k1. So this implies we get this one x1 equal to k1, x2 equal to minus k2. This one x1 equal to k1, not k2. This is also minus k1. This one. This is 1 k1 minus 1 k1. Therefore, x1, x2, this is k1 minus k1. We get this one. If we consider k1 common, then we get this is k1 1 minus 1. We get this. This is the first eigenvectors. Next we consider case 2. In case 2, let lambda equal to 6. We get two eigenvectors 1 and 6. First we putting 1, we get this relation, and putting 6. 6 we putting here, 1 implies 5 minus 6 x1, 4 x2 equal to 0, x1 2 minus 6 x2 equal to 0. So this will be minus x1 plus 4x2 equal to 0. This is x1 minus 4x2 equal to 0. So this one you consider number 4. This is 5. But both the equations are same. If we multiplying by minus 1, then we get this equation. Now 4 implies x1 equal to 4x2. So x1 by x2 equal to 4 by 1, or we can write x1 by 4, this is x2 by 1, this is k2, say we consider k2. So this equal to x1 equal to 4 k2, x2 equal to k2. Therefore x1, x2, eigenvectors actually consider x means x1, x2, x1, x2, this is 4 k2, k2, and k2 common, this is 4 1, 4 1, we get this one our answer. 4 1 is our answer. This is the second eigen vector. Therefore we can write these are together. One eigenvector is this and another is this. Therefore the required eigenvalues are 1, 6 and corresponding eigenvectors are 1 is k1 1, minus 1, another is k2 4 comma 1. These two are eigenvectors. So these two are our answer. Very easy solution but most important. There another problem. Determine the eigenvalues and eigenvectors of a equal to -5 to 2 minus 2. Solution. The characteristic same problem equation is determinant a minus lambda I equal to 0. So -5 minus lambda 2, 2 minus 2 minus lambda, this equal to 0. So this implies -5 minus lambda minus 2 minus lambda minus 4 equal to 0. 10 plus 5 lambda plus 2 lambda plus lambda square minus 4 equal to 0. Lambda square plus 7 lambda plus 6 equal to 0. Lambda square plus 6 lambda plus 6 equal to 0. And lambda common, lambda plus 6, 1 common, lambda plus 6 equal to 0. Lambda plus 6 common, lambda plus 1 equal to 0. So lambda equal to lambda plus 6 equal to 0, lambda plus 1 equal to 0, and this implies lambda equal to -6, lambda equal to -1. So we get eigenvalues are -1, -6, these two. Next you have to find eigenvectors. For eigenvectors, now we have to write a minus lambda I x equal to 0. A minus lambda I x equal to 0. So this implies a minus lambda I, this is the value, -5 minus lambda 2, 2 minus 2 minus lambda, x means x1, x2, and 0 means 0, 0. We write in this way. So this implies this will be -5 minus lambda x1 plus 2x2 equal to 0. This into this equal to 0. And 2x1 minus 2 minus lambda x2, this equal to 0. This. So this 2 we consider 1. Now case 1 we consider let lambda equal to -6. 1 implies we putting lambda equal to -6 in equation number 1. Then this is -5 minus -6 x1 plus 2x2 equal to 0. 2x1 minus 2 minus -6 x2 equal to 0. This is x1 plus 2x2 equal to 0. 2x1 minus plus 4 plus 6 plus 4 x2 equal to 0. So we get this. So this is number 2 and this is number 3. Both are same equation. If we dividing this one by 2, then x plus 2x2 we get. Any one of this we solve. Now 2 implies x1 equal to -2x2 and x1 by x2 equal to -2 by 1, -2 by 1. So this is x1 by 2, x2 by 1. This is k1 we consider. We consider this is k1. This implies x1 equal to 2k1 and x2 equal to -k1. This -k1. and therefore we can write x1 by x2 2k1 minus k1, and k1 taking common 2 minus 1, we get this is the first eigenvector. Next we consider case 2. Let lambda equal to minus 1, another value is minus 1. We putting minus 1 in equation number 1. Now 1 implies minus 5 minus minus 1 x1 plus 2x2 equal to 0. 2x1 minus 2 minus minus 1 x2 equal to 0. And this implies minus minus plus minus 4x1 plus 2x2 equal to 0, 2x1 minus x2 equal to 0. So both are same equation. This is number we consider 4 and this is 5. Now suppose 5 implies any one of these. 5 implies 2x1 equal to x2, x1 by x2 equal to 1 by 2, x1 by 1, x2 by 2. This one here, this one here. This is k2. We consider this one k2. Now if we solving this, x1 equal to k2, x2 equal to 2k2. This implies x1 equal to k2, x2 equal to 2k2. Therefore x1, x2, this is k2, 2k2, and k2 is common, we get 1, 2, we get this one 1 and 2. Therefore the required eigenvalues are k1 2 minus 1, k2 1 2, and the corresponding eigenvectors are so I have mistake this. This is eigenvalues are required eigenvalues are, this is one is minus 1, minus 6, minus 1 and minus 6, and corresponding eigenvectors are, this is k1 2 minus 1 and k2 1 2. So these are the answer: minus 6, minus 1, minus 6, and eigenvectors are 2, minus 1, 1 2. These are the answer, and these are very easy, very simple, very interesting. I hope you are all enjoying with me. If you are all enjoying, then please share this video to other engineering friends also and other BSc friends also. Thank you for watching the video.